All right, let's talk about one of the most basic instruments you'll find in any cockpit, the magnetic compass. I mean, it seems so simple, right? It points north, you follow it, job done. But what if I told you that simple little instrument has a secret, a quirk, that every single pilot has to know to fly straight? Okay, let's get into it.
So, picture this. You're up in the air, maybe flying through some clouds, and you're counting on your compass to tell you which way is which. But what if, in those crucial moments, it's, well, not telling you the whole truth? It's not broken, but it's definitely lying to you. And that's the big question we're going to answer today.
And yeah, it's true. Your compass can absolutely lie to you. Not all the time, but in some very specific situations, especially when the plane is turning, that trusty little instrument can give a pilot a totally false reading. And you know, understanding this lie isn't just some fun aviation trivia. It is absolutely critical for flying safely.
So what's going on here? Is the compass just busted? Nope, not at all. It's not a malfunction, it's just physics. The secret culprit behind this whole thing is a really fascinating force of nature called magnetic dip. And that's what we need to wrap our heads around.
You know, when we think of a compass, we picture that needle pointing flat, right? Horizontally towards north. But that's really only half the story. See, this thing called magnetic dip means the needle also wants to point down, literally, down into the ground towards the magnetic pole. The Earth's magnetic field isn't just flat. It has a vertical pull, and that pull gets a lot stronger the closer you get to the poles.
Here's a good way to think about it. Imagine a flat paper map versus a globe. On the map, all the lines are straight and parallel, but on a globe, they curve and all come together at the north and south poles, right? Well, the Earth's magnetic field is way more like that globe. It's this big, three-dimensional force field that curves and, you guessed it, dips down. And that's the force that's messing with our compass.
Okay, so we've got this dipping force. Who cares, right? Well, pilots care. A lot. Because this is where the theory becomes a very real problem inside the cockpit. It's what causes something pilots call northerly turning errors.
The key thing to get here is that this downward pull really only becomes an issue during turns. Think about it. When the plane banks into a turn, the whole compass housing tilts with it. And that delicate little compass card inside? It gets tilted too, and suddenly, that downward dip has a chance to pull the card and just yank it off its correct heading. That's exactly where the error comes from.
So here's how it plays out, at least here in the northern hemisphere. It's kind of weird. If you start a turn towards the north, your compass gets lazy. It actually lags behind the turn. But if you turn towards the south, the complete opposite happens. The compass gets all excited and leads the turn, jumping ahead of where you actually are. So, you've got this compass that's lagging one way and leading the other. How in the world do you fly accurately with that? Well, pilots have a secret weapon, a simple but absolutely brilliant little memory trick that every single one of them learns from day one.
And here it is. UNOS. That's it. UNOS. Undershoot north, overshoot south. I guarantee you this little acronym is seared into the brain of every pilot. It takes all that confusing physics we just talked about and boils it down into a simple, clear command.
So, let's put it into practice. Say you want to turn and fly due north. You know your compass is going to lag, so you start your turn, but you stop turning before the compass actually says north. You undershoot it. Now, what about turning south? You know the compass is going to jump ahead, so you fly past your target heading on purpose and then roll out of the turn. You overshoot it. See? So simple, but so incredibly effective.
Now, UNOS is a fantastic trick for dealing with that old-school magnetic compass. But let's be real, in a modern cockpit, pilots have an even better tool to make sure they're flying on a precise heading during a turn.
But before we get to that, let's just recap the whole problem, because this really nails it. Your compass dips when you turn, and that's what makes it lead or lag. That's the heart of it. It's just a built-in, unavoidable flaw of trying to use magnetism to navigate in a vehicle that's banking and turning through the sky.
So what's the ultimate pilot pro tip? It's this. Trust your DG. That's your directional gyro. Basically, it's a very fancy, very stable spinning top. And the beautiful thing is, it doesn't care about magnetism at all. It runs on gyroscopic principles, so it isn't affected by that annoying magnetic dip. So, what a pilot does is get the plane flying straight and level, sets the DG to match the magnetic compass, and then when it's time to turn, they pretty much ignore the magnetic compass and trust the DG. That's the reliable instrument. And you know, that kind of leaves us with a pretty cool final thought. We just uncovered how this totally invisible magnetic field can play tricks on one of our oldest, most trusted instruments.
It really makes you think, doesn't it? What other unseen forces, from gravity to air pressure, are out there all around us, constantly shaping the world we navigate every single day? Something to think about.